Next, we're going to dive into another UNIHIKER project. Here, we're faced with a question: how can we use UNIHIKER to create an interactive project that produces sound? There are mainly two different ways to create sound-producing projects with UNIHIKER. The first method involves using the built-in buzzer. The second method involves connecting a USB speaker. Let's look at the first method. I'm sure you're all familiar with buzzers. So, how do we use the buzzer on UNIHIKER? The programming instruction modules we'll be using are in a specific section. You can find this small title and the corresponding programming modules in the software. With these programming instructions, we can directly play the program's built-in music melodies. Back to Mine Plus. As you can see, we can use this module to write our own music melodies, just like playing an instrument. You can set the melody and rhythm, and you can choose the notes you want to write in the bass, mid, and treble ranges. Click here, and a piano keyboard will pop up below to help you select the notes. If you've learned to play an instrument before, this task should be even easier. Next, let's do a simple exercise. You can try using UNIHIKER's built-in buzzer to write and play the first two lines of Twinkle Twinkle Little Star. Please feel free to hit pause, go back to Mine Plus, and spend a few minutes to complete this mini exercise. This is our complete reference program. All you need to do is to choose the corresponding notes and beats according to the melody. Next, we'll try the second method of producing sound, which is connecting a USB mini speaker. Similarly, when using a USB mini speaker, you have corresponding programming instructions. You can find their modules in this area. Before we start writing the program, please connect your USB mini speaker to your UNIHIKER. Additionally, we need to understand how to use the built-in buttons, Key A and Key B, on UNIHIKER. What we want to achieve is that when we press Key A, UNIHIKER automatically records for 10 seconds. After 10 seconds, when we press Key B, the sound will automatically play through the USB mini speaker. That's the effect shown in the video below.
Wait, wait, wait. Wait.
Next, please take 2 minutes to try it out yourself. If you don't have a USB mini speaker at hand right now, it's okay. You can try to write the program first and compare it with ours. You can refer to it when making similar projects in the future. Okay, let's see how to implement such a program together. In the instruction module area of the onboard sensor, we can find the module when A is pressed. We drag it out and put it in the programming area. We can find all the control instructions for the onboard sensors in this area. Next, we need to find the programming instruction module for recording. Scroll down, and we can find the instruction area for audio recording and playback. Here we select the first module. The fourth module below is our audio playback module, and we also take it out and put it in the programming area. Here our programming logic is to first judge whether the button is pressed. If it is, then record or play the sound. The logic judgment module of the program is at the top. Click on Control, select the If, then module. Also, put it in the programming area. Next, we will write this program. We put the judgment condition, if A is pressed after if. Then put the sound recording module inside the condition judgment module. This means that once the condition is met, that is, once we press Key A, UNIHIKER will start recording audio for 10 seconds and name this audio record.wav. The function of pressing Key B is the same logic. We can directly choose the right button to copy this set of modules. Change the drop-down menu Key A to Key B or drag to delete the recording module inside and change it to the module that plays this recording. Then we connect them together and put them into the loop execution. Then, we can also let the screen display the name of this project, Retro Tape Recorder. You can connect your device and then click Run to test the effect. This is the first effect we aim to achieve. However, you may notice some glaring issues with this project. Firstly, it's not aesthetically pleasing. How can we quickly transform it to look more like a vintage recorder? The answer is simple, by displaying a vintage recorder image. For this, we first need an image. You can click pause on this screen and take a screenshot for your reference. Please save it on your computer. Next, let's return to the programming software and see how we can use Mind+ to display this image on UNIHIKER. At the top left of the interface, just below the Python mode, click on a file system. A menu will pop up. Open the folder, locate the image we just saved, click and hold the image, and drag it to the line of text under the files in the project. You'll notice that an orange line lights up just before you release the image. Upon release, the image will appear here. This is the fastest way to add an image, and it's particularly handy when we need to add many. Next, we can use a programming instruction to display this image on the UNIHIKER screen. The third instruction under the screen display is the module used to display images. Here, we need to change the image name to match that of our image. You can just copy it from the file system. After adjusting the name, click on a file system again to hide this area. Click Run to preview the effect. You'll notice that, by default, the image uses the top left corner as the origin. Please keep this in mind when adjusting its position. Next, considering the image is quite large, how can we make it fit the screen perfectly without exceeding the boundaries? This instruction doesn't provide an option to adjust the image size. That's because the size of each image is unpredictable. Therefore, the fastest way to adjust it is by setting its length or width, which will proportionally scale it up or down. For this, we'll use the update object module. Drag out the first module under Update Object. Click on X and you'll find the width option in the drop-down menu. Select width, then change the object name to match the name we gave our image. Set the width value to match the screen width, which is 240. Now, if we click Run and test it again, you'll see that it fits the screen perfectly. Similarly, if you want to adjust the display size of the image, you can use this programming instruction to proportionally scale the image by setting its width or length. Of course, this project isn't fully complete yet. Can you spot any obvious issues? From a user-friendly perspective, when we press this button, we don't know whether it has started recording or if the recording has ended because the interface remains static. Next, you can follow the functions presented in this video, or you can incorporate more of your own designs.
Do, re, mi, fa, sol, sol, fa, mi, re, do. Do, re, mi, fa, sol, sol, fa, mi, re, do.
Let's have a few minutes to improve this project. Here, we just need to update the text content of the display object based on the state. All you need to do is to update the text color and content displayed on the screen during both the recording and playback modes. That wraps up our project. If you want to further improve this project, you can do so after the class. In particular, we learned how to use the A and B button to switch screen display states and how the A and B buttons can simulate commonly used buttons in our daily life to perform corresponding functions. In addition, you can make a touch electronic piano by combining the touch screen function of the UNIHIKER screen.